Thanks. So I'm guessing, judging by the title, you figured out that C# is being updated, which isn't really that odd since we've had updates for C# since the first version was released. We've had continuous updates to the language. So first off, I'd like to thank the sponsors for making this day possible and for making it possible for both you and us, for both you and me to be here. And I'm Philip Ekberg. I'm a C# MVP. Wrote the book called C# Smorgasbord, which you all should get after this talk. And I work as a senior consultant for Redify. If you have any questions at all during this talk, please feel free to interrupt me. I'll be happy to answer anything. If I don't know the answer, I'll try and figure it out afterwards. You can also hit me up on Twitter. So before we start talking about the changes coming in the next version of C#, I'd like to talk about the brief history of what we've had coming up until today. So first of all, after the first release of C#, we got C# 2.0, which introduced quite a lot of new features to the language. I'm not sure if everyone remembers, but we got generics in C# 2.0. I'm guessing a lot of us use generics quite frequently. We got partial types, which we're probably using if we're doing WPF or WinForms. Got anonymous methods, iterators, nullable types, getters and setters with separate accessibility, and static classes, and a few more things. So seeing this introduced as a second version of C# kind of indicates that the language is living, it needs to be refreshed, and it needs to follow the patterns that developers like to code in. After that, we got C# 3, which introduced quite a lot of features as well. We got implicitly typed local variables. I remember when this was introduced, people started asking about, is C# now a dynamic programming language? Because they no longer had to write the explicit type before their variables. So we could start using the var keyword, which made everything much nicer to read. We got object and collection initializers, which I personally use a lot, together with everything else, of course. We also got auto properties. We had properties in C# too, but the auto properties help reduce the noise of these properties. Anonymous types, extension methods, query expressions, lambda expressions, and expression trees were also introduced in C# 3. These features made it possible for us to use language-integrated queries, and they made our experience using the programming language much more nice, especially when we're working with link to SQL, link to EF, link to object, link to XML, and so forth. And there's a few more things which aren't worth mentioning right now, but these are the biggest features introduced in C# 3. So in C# 4, something happened. We didn't get quite as many features introduced into the programming language. And the reason for this is probably because Microsoft started working on something else. We got dynamic binding, which means that we could now do dynamic programming as people thought they were doing with the var keyword. But now we got proper dynamic programming inside C#. This isn't by any chance a small feature to add to a programming language. And we also got named and optional parameters. Optional parameters made it possible for us to avoid creating a lot of overloads for our methods. We could instead just append optional parameters and let people pass them on if they'd like to. We also got generic contravariants and also a few other minor features. As we see here, there were quite a decrease in the amount of language features, even if the dynamic addition to C# was quite big and radical. Now this gets pretty more obvious when we talk about C# 5. Can anyone remember what we got in the previous version of C# 5 or previous version of C#? If you thought about asynchronous methods, that's pretty much it. So they made it possible for us to use async and await inside our C# programming class, inside our C# programming. This makes it easy for us to create asynchronous APIs. It makes it easy for us to consume asynchronous APIs. This is also a pretty large language feature to add to a programming language. It's really just syntactic sugar, and they're adding a lot of things behind the scenes, but they're generating things for us that we don't need to think about, such as the state machine and handling all that for us. We also got coloring for attributes, which isn't as big as a feature as asynchronous methods. So Microsoft kind of decreased the amount of features they gave us, even if they gave us quite a lot of features. And this is mainly due to the state of the compiler. The compiler has been written in C# from the start, And they've added features, added features, added features. And we all know that if we have a legacy code base that we just keep adding things to, it's going to get hard adding new features and new things. So it's difficult for Microsoft to add new and shiny things to the programming language without implicating other things in the compiler. So it's really been a black box from a developer's perspective. It's been really difficult for us to say, hey, I want to analyze this C# code file, or I want to do some specific refactoring on a specific type of code. That hasn't really been possible using the old compilers. We've been able to tell the compilers that here is a C# file, compile that and give me the results. And if there's a problem, it'll tell us there's a problem, but that's basically it. So this is where we're getting Roslyn to the rescue. Roslyn is an initiative from Microsoft to rewrite the compilers in a native programming language. So quite a few years ago, they announced that they were starting to rewrite the compilers, and they were doing this side by side, working with new language features in C#. Rewriting the compilers also means that they need to replicate the bugs in the old compiler, which is quite interesting. So this is called the .NET Compiler Platform. It also incorporates the VB compilers. So the compiler is completely written in C#, and that means that we can take advantage of the nice unit tests that we can write, and they can manage the code much easier, and they can introduce new language features in a much more easier manner. And the best part about this is that it's open source. So you can go ahead into Codeplex, you can download the new compiler, you can fiddle around with that, and you can add your own language features. I saw someone adding a few new language features. I saw someone translating the entire C# to a different language. All the keywords were written in Swedish, which was pretty funny because I'm Swedish. So that's probably why I saw that. But you can do that, and you can submit pull requests. You can go ahead and read the design documents. You can see what the thoughts are behind the language features that they are introducing. It's not an easy task working or writing a compiler, so it's really nice for us to be able to see what kind of thought process goes into this. So inside C#6, we're getting quite a lot of new interesting features. We're getting something called auto property initializers. I'm going to go through these here in more depth, but I'm going to show you an overview of all these language features that we're getting. So we're getting auto property initializers, which also includes getter-only auto properties. We can assign getter-only auto properties from the constructors. We get parameterless struct constructors. We get using statements for static members, dictionary initializers, awaiting, catch, and finally, exception filters, expression-bodied members, null propagation, string interpolation, nameof operator, and there might be a few more things. So comparing this kind of toolbox of language features to what we got in C#5, this is quite substantial. We're getting a few more very nice features. Some of them are just syntactic sugar that lets us write less code, and the compiler takes care of generating everything for us. But it's pretty nice to see that the initiative of rewriting the compiler has paid off. It's easy for them to introduce new features in the programming language. The first feature that we are going to talk about is the auto property initializers. The problem with auto properties is that, in this case here, in order for me to instantiate this here, set the name to something default, like anonymous, I'd have to introduce a constructor, which is kind of boilerplate, and I don't want to do that. So in C#6, we can simply say that this property is initialized with this value. And likewise goes for getter-only auto properties. So in this case here, we can create a true read-only model. I can say that my person here is instantiated with the name anonymous, and you can change the name. This helps us do true immutable types. Yep.
Does the anonymous or whatever you're trying to have to be compiled from constant? Or can you do reference types?
So you're asking if that needs to be a constant?
Yeah.
That's a very good question. We can try that out later in the demo. I don't have the answer right now. Another example of this is to do this from the constructor. So we can set this getter-only, read-only field from the constructor. I can instantiate this with the name Philip. And when this is decompiled, we have the backing field here. It's taking out Philip, and it's instantiating that field with that value. So we're getting a true read-only model here, which means that we can create true immutable types. In a real world, of course, we would ask the constructor to take the name, and then we set this auto property from within the constructor. So the next one is parameterless struct constructors. How many of you in here use structs on a daily basis? 1, 2, right. It's a pretty cool feature. You haven't been able to use auto properties like this in structs before, so you can also use these language features now in structs as well. And if you want to set these to initial values, you can now introduce a parameterless constructor. What you've previously had to do with a struct is that you need to say that the parameters to the constructor needs to be something. You can't just do it without parameters. This will also be read-only. So this example here is pretty bad. Why would you create a struct as a point, set the coordinates to something that you can't change? So you see here that when we decompile this here, it'll set these fields as read-only as well. So a more proper example to do this is that you want to introduce a parameterless constructor that calls another constructor with the default values. So now that you can do that with a struct, you could say, for instance, that the default values will be 0, 0, but that's the default value of int anyways. But if you have other types, which isn't in this case coordinates, it could be whatever you'd like it to be. It's quite handy for the people working with these kinds of data models. So using statements for static members is another language feature that people tend to get a bit confused about. And you'll see here why in a few seconds. So imagine in this case, I want to print out the sine of an angle. I want to print this out to the console, and my application contains of a lot of console write line and whatever math method I want to call. Wouldn't it be pretty nice if I didn't have to prefix the method call every time? So what we can do now with using statements for static members is that we can make this line here a bit cleaner. I can instead say that I'm using everything from console and everything from math, and instead just write line and the sine of the angle. So what happens here is that behind the scenes, it's going to rewrite this to what we saw in the previous slide. So it's just syntactic sugar for not having to be redundant about what we're doing. Now the problem with this though is what happens if we introduce our own method? What happens if I create a write line inside my class with the same parameters and the same signature? It will pick the one closest to itself, which makes more sense. So if I introduce a static write line method inside my program here, it'll go to that instead. And Visual Studio 2015 will tell us that the using statement for system.console is no longer important, or it's no longer used. What we can also do is that we can change that using statement for using system.console to use, for instance, the debugging instead. So instead of writing out to the console, we write out something to the debugger with just one line change. This starts to get pretty dangerous, getting people to change just using statements, and it changes the entire behavior of your application. But with great tools comes great responsibility. Here's another example where I'm doing this with system.link.enumerable. I want to iterate over a range of numbers. Instead of having to write enumerable.range everywhere, I can simply say that I'm using this, all the static members from the enumerable class. So I can here iterate over all these numbers from 0 to 9. Next up, we have something called dictionary initializers. We've had dictionary initializers in the past. The difference now is that the dictionary initializers that we have today are proper initializers. The old way of doing it is calling the dictionary.add method, which is a bit different from what this will do. So in this case here, I say that I have a dictionary of people, and I'm using the index of the person to set that to a new person. So what will happen here is that it'll actually break this out and use the proper index when initializing this value instead of calling the add method. Of course, we could do this with other types as well. So here I have a dictionary of answers. So the answer to 42 is the answer to life, the universe, and everything. And we also have await inside finally blocks. When they released async and await, a lot of people were kind of bummed out that you couldn't do awaits inside catches and finally blocks. The reason for this is if you call a service or something and then you want to clean up the resources after you're done, that cleanup method might be asynchronous as well. So what you would end up doing is that you'd have inside your catch block, you'd say, hey, did this fail? Do I need to clean up after the try catch? And you'd have to move that statement after the try catch block. Now with C#6, this gets a bit cleaner. You can now use awaits inside catch and finally. The reason that Microsoft didn't introduce this in the first version of C#5 with async and await is that it's pretty tricky to do this when inside the internal state machine. So you see here that we can await inside the finally block. Next up, we have something called exception filters. Imagine yourself having a lot of exceptions, and if you're doing exceptions properly and catching not only the type exception, you're catching the proper exceptions, you might want to filter based on different severities inside your exception. So in this case here, I have a custom exception which is being thrown inside my application. Now I'd like to catch this exception and check what's the severity. If the severity is above 50, for instance, I'd like to send an email to my boss or to my coworkers. If it's less than that, no one cares. So the way that you would do that before is that you catch the custom exception, and then you have an if block inside the catch, and based on that, you do something. You don't have to do that with C#6. You can simply add an if block after the catch statement. So I'm saying here that catch the custom exception if the exception severity is above 50. And of course, what happens after this is that I want to catch all the other exceptions and maybe log to disk or something else. So you can, of course, do that as well, and it will work its way down the order. So you could also catch all of the exceptions after this. Now, one of my favorite features being added to C#6 is null propagation. Has anyone in here got null reference exceptions anytime? This week, maybe? Today? Yeah, it happens a lot. Doesn't really matter how good of a developer you are, you always end up getting null reference exceptions. And I blame the users of my systems for not giving me the right data. So in this case here, I have a person and I have an address. A pretty common case is that this is being submitted over the web or inputted from a system. The person that inputs all the data enters the personal details but forgets the address, so that model won't be populated. Now in this case here, I'm setting up my person here. Imagine this being injected into an MVC action. So we just have the name. So what happens when we try to write out the person's address? This will blow up in our faces. This happens quite often. The way that you solve that is that you say, if the address of Philip here isn't null, print out the address, otherwise we were saying that he has no address. Although if Philip here is coming from a MVC call, then the person itself could be null. So we have a bug in this code that this could in fact throw an exception when we do Philip.address. So with null propagation, this gets quite easier to fix, and it also fixes this bug. So what we're doing is that we're adding a question mark. I think it's called the Elvis operator. Someone tweeted a picture that it looks more like Tintin, like the little thing on the head here. So this here will ask, if Philip isn't null, go ahead and go over to the property address. If the address isn't null, go ahead and go over to address line 1. And if any of these here are null, it'll evaluate the entire expression as being null, which means that we can do the double question marks afterwards and say that there's no address. It gets a bit cleaner, and it's easier not to make any mistakes. So let's look at using this in another scenario. So this is an array of people. The first person here is just instantiated with whatever. He might have an address. The other one is completely null. So this means that this will probably work. If name here is just a simple string, it'll just go ahead and go into that object. Next up here, we're trying to access the first object and go ahead and go over to the name property. But in this case here, the object that we're getting back is in fact null, so it will evaluate this entire expression as being null. So it'll just be a blank line printed to the console. Now imagine the entire array being null. Would you still have to do an if the array isn't null? How many of you think that you have to do an if block outside first and ask if the array is null before you do the Elvis operator? No one? That's correct. You can simply append the question mark before the index of the element inside the array. So you could say here, if the people array isn't null, go ahead and check the first index. If that isn't null, go ahead and check the name. And all this will be decompiled into something looking like this, which is a lot uglier than the first two lines. It'll first ask if the people isn't null, do the next one and check all the nulls, and it just gets horrible. It's so easy to get that right line wrong. It's much easier to get it right using the null propagation.
If you're doing property access, you also won't access block as well, is that right?
Sorry?
If you went person.address.suburb.postcode or something.
Yep.
It's not
So your question is, if I do that,
Like if you wrote it out this way, it's going to call something twice, so it's going to evaluate the sigma null, it's going to evaluate the actual value. But it won't actually do that with the way to compile it real.
it would probably do that. It would probably use it twice, since it's decompiled to what you would write in the normal case.
Also, it does go to the factor that's
Yep. Yep. So this is, I took this from Reflector. I wrote this code, decompiled it using Reflector, and just brought it in here. So it needs to do that. It needs to, so your question was, if I have a long path down to an object, if it will call most of them twice, and it needs to do that because it first needs to check if it's null, and then go on to it, and then it'll need to check the second one if it's null. Does that make sense?
Yes, it's not stashing the variables, it's checking the variables.
No, it's not stashing them or caching them anywhere. Yep.
Kind of following up on that, is this just properties or is this methods, functions on that?
It's method as well. So your question is if you could use this as, with methods? Sure.
And then is that going to be a problem if it's double twice? If you're calling a method twice and not stashing it?
That's a very good question. Do you want to try? We can try it. Let's do it. Let's go off script. So your question is if we have a class person, and inside here we have an address, and the address has a method that returns something else.
Yeah. Or maybe makes a change. Person has a method that returns address.
That's a good one. So person has a method. Let's do that. So this will return nothing at all. So now the question is, if I do a new person, and let's add a property in here. What happens if I do Philip dot get address? And then I want to access the address line 1. Oh, sorry. See if this works. What happens if I do that? Is that the question? Yep. All right. So this will most likely blow up since it's going to return null. Let's just verify that first. Oh, what's up? All right. So that blows up. That's good. Now how can we fix that? The first check would be to check if the person is null, and that question mark there. And the second one is to check if what's returned from the method is null, right? Let's do that as well. Now, if this blows up, which it shouldn't, we will be in trouble. Now, let's see what this decompiles to. Let's have a look in Reflector.
You just put a console right line and get address and see if it comes out for.
Sure.
Oh,
I could do that. Call once. Do you want to see what it's decompiled to? Sorry? You were saying don't return null? Do you want to return a new address? That wouldn't break it though, but sure. Yep. Just like that. And then let's decompile this and see what we get. This is very exciting. I have no idea. There we go. So it does call get address twice. Yep. So call it once. Yeah, probably. So I'm betting that Reflector isn't really up to date to what this is returning. We could go in and look at the IL, but that would probably take more than the time I have. So let's go back. So we didn't call it twice. We didn't get 2 console write lines. And remember that I'm compiling this in debug mode. If we compile in release mode, it might do something differently. We all happy with that? Let's get rid of this here. All right. The next one is expression-bodied members. So expression-bodied members makes it easy for us to use expressions to define methods. In this case here, I want to create a property, for instance, that calculates the area of this rectangle. I have width and height. I just simply want to return the multiplication of those two. The way that we can do that now is by saying we have this property called area, which returns the width multiplied by the height. Now this is pretty cool, but we could do even better. So let's say that we want to print out the value of width and height to our console, or get the value of them as a string representation, which means that we would have to override toString. We can do that with expression-bodied members as well. So in this case here, I'm saying that we have an override of toString, and it returns whatever this expression evaluates to. I'm also hinting the next language feature in here, which is string interpolation. A funny thing about this feature is that a few years ago, I wrote a blog post asking the community what language features they'd like to see in C#, in the next coming versions of C#. A lot of the features people name-dropped have come into the programming language, which is pretty cool. One of the comments was from Miguel de Casa, the author of Mono. He told me that he'd really like to see string interpolation and showed me how he'd done it in Mono. And now we're getting that, which is pretty cool. So it's nice to see that Microsoft is taking feedback from the community and asking devs as us what they really like to see in the language. So string interpolation is about embedding our properties, for instance, or our method calls inside the string itself to make it easier for us to read it and to make it easier for us not to make mistakes. I'm guessing everyone in here using string.format, and everyone has got the order wrong sometime, or added more arguments that you have or less arguments. This makes it much easier not to do those kinds of mistakes. I do want to tell you, though, that all of these features are still work in progress. So this feature will actually be changed. The syntax will actually be changed in a following release. However, in Visual Studio 2015 that you can download today, the one on the top here is what you'll be using. However, in a following version, they want to conform more to what we've done with string.format. So they're going to introduce this $sign to remind us of PHP developers. And then we are going to be able to incorporate the properties or method calls inside the string. I think this is pretty cool. It'll be very useful when we're doing inline SQL queries, so we can really avoid all those SQL injections. All right. So this here will be decompiled to a string.format. It's simply syntactic sugar for generating something that looks like this. What this means is that we can use everything from string.format to format our string in here as well. So we can say, for instance, in this case here, I want to print the H, but I want to format the number to be 5 digits. So I'm using my string interpolation, doing a colon and saying, hey, I want 5 digits, which is pretty simple. And also note here that I'm getting IntelliSense on this. So it's a black here to indicate that the environment is telling me that I can access properties. It's going to show me all the methods and do all that. So this here will write out, hey there, I'm 000028 years old. And it'll be decompiled to something that looks like this. The string.format version it's just a minor thing, but it makes it easier for us to not get the problems that we could generally get with string.format. And also note on the top here that the result is a variable. You don't have to pass this to a method. You can declare this using string interpolation pretty much anywhere. There's an entire dictionary on Codeplex where Microsoft shows what types of formatting you can do and all the things they're doing to make string interpolation work. Looking inside the compiler and seeing how this works is pretty awesome. The final operator I want to talk about is the nameof operator. The nameof operator is a pretty minor feature, but think about the times where you want to print out something to the console and say, hey, you called my method with this argument, the argument was out of range or something like that. All the times you would like to say, in this case, I want to say, hey, the name of the argument passed to main is something, you'd have to do that in line in a string. With the nameof operator, you can simply say, give me the name of this property or this argument or whatever. The benefit of this is that it's very nice when you're doing refactoring. So I, for one, have, when I'm doing logging or things like that, I'm hard coding the variable names or the method calls, and then I refactor all the things, and the logs doesn't make sense anymore. Especially when it goes a few years and you work on a legacy code base. This here lets us get around that. So this will write out parameter name is args, which is pretty handy. Here's another example of that. We can say, for instance, that when the width for the calculated area is below or equal to 0, we want to throw an exception, and we want the exception to tell us which argument was invalid. So I'm going to throw an argument exception here and say that the parameter width cannot be less than 0. And with the new syntax of string interpolation, using the $sign and not having to use the backslash, makes it even cleaner. All right, so let's take a look at the language features in Visual Studio 2015. You said something, Turtle?
Is the name of decompiling to reflection some stuff?
We can have a look.
Which obviously in turn has its own implications for it.
Yep. So it's the nameof operator. What does that look like when we decompile the application? That's a very good question. So let's start off by adding one of these language features, which is the using statements for static members. So I want to bring in system.console. Notice here on the top, though, that it's going to tell me that I'm not really using this. So I could remove it, and it'll give me a nice overview of what happens when I remove it, what the implications are. So this is a pretty nice feature in Visual Studio 2015. And Visual Studio 2015 will be the first Visual Studio version shipped with the new compilers. So when you get this and you start working with C#, it'll use the Roslyn compilers behind the scenes. So now I want to do write line. And notice here that it shows up when I do IntelliSense. I can say the, let's say, the arg past name is args. So we get IntelliSense in here as well. That's pretty nice. One of the things they're really focusing on when introducing new language features is that the IDE also needs to be up to date with all the language features. So if they're adding something that implicates the C# language a lot, they also need to update the IDE, that being Visual Studio, to keep up with that and to give us nice IntelliSense, for instance. So let's do this. Let's run this and verify that it works. Oops. Now, if we go ahead and open this up in Reflector, let's see what it says. So it'll pass that. This reflector is telling us that it's doing this. It's passing that as an object array, passing it on to string.format, and then string.format probably knows how to handle that. Yeah, this is using the nameof operator behind the scenes. The compiler is understanding what the nameof operator is doing and rewrites that to something else. So it's just syntactic sugar. Oh, sorry. Oh my God. Oh, that's embarrassing. Who said that? I'm going to give you a free book. Oh, sure. Thanks. So the name, the argument passed name is args. Now we're really using the nameof operator. So let's head over to Reflector and see what happens here. I really don't believe it's going to give us the same thing. Interesting. Oh, right. Yeah, thanks. Here we go. Right. So what the compiler is doing is that they're reading the name of that argument when it's compiling. Since there's no metadata passed on to a binary, it takes that and puts that into a string and then do string format for us. And there was another question up here in the beginning with one of the operators, new language features. Does anyone remember the question?
There's a constant question. So
With auto properties. Yep. So if we do a class person, and we do let's do a static method in here. So your question is if I can do property person parent equal to whatever that returns. Would I? So it's pretty cool if it works. It should work. Because what it's doing behind the scenes is that it's simply just pulling this out, putting that inside the getter. So what it will do is that it will call this method inside the getter. So you can put whatever you want here. And looking at the decompiled version of this, we'll see that this is in fact true. Sorry? I'll show you what happens. So we have the person class in here. We have the parent. It's a simple property. The backing field, however, let's see if we can expand the methods. The backing field will be set to whatever program.getPerson returns. So you could pretty much do that. Now, the other language feature, another thing that inside Visual Studio that I like to show you is if we use the enumerable range, I'm going to do using system.link.enumerable. And you see here that we get IntelliSense for the static members that we can include as well. So we could do var range is equal to range from 0 to 1000. Put a breakpoint here. So how many of you have had problems when you run your applications and you have Lambda expressions and you can't debug the Lambda expressions and everyone gets pretty angry? Like everyone, right? Okay. Look here. Is it correct? Ah, right. Two things I want to tell you about that. Didn't work. So they've rewritten the entire watch window. However, you need to include the classes inside your inside the class that you're debugging to be able to use the namespaces. So now let's take a look here. This is very, very exciting. I have a Lambda expression here. Hit enter, and I need to click this as well. It's evaluating the expression, and now we got an array of numbers. It's pretty exciting. It's pretty cool. It's been something that I really hate for a long time. So you saw here that I have a Lambda expression, right? We can also use this syntax here. So if I just evaluate this expression, we'll see here that it selected all the ones less than 10. So now we can debug our Lambda expressions. We can pull in the Lambda expressions here and use them in the debugger. It's not a language feature, but it's a really nice add-on to Visual Studio 2015. Sorry? Yep. So your statement was that you can also do this in edit and continue, and that's correct. They've done a lot of work on the things that really annoys us, which is really good. So let's get on with this.
So what we question about nameof?
Yep, sure.
When you do nameof person.address, I remember reading in code like this and angst about what that should do. Is it going to give you just address, or is it going to give you person.address, or what would nameof do if you do something like compound?
What will nameof give us if we, okay, let's bring in the person again. So your question is, what will nameof give us if we have a long path to properties and so forth?
Yeah, or even if you ask one or something like
Yep.
That was discussion.
Let's just add a so your question is, what happens if we do a console write line and we do the name of a new person dot address? All right, sorry. That's not going to work. So is your question, what happens if I have this here?
Well, yeah, I know.
Yep.
There's a lot of that.
So if I do this, it would, and I say name off here.
Well, not so much that. No, not like that. Don't give you X on that. But if it was,
Yep.
It was X as a new person into X dot address dot line one inside the name of operator.
Right. So if I do line 1, you can't do that. Yep. Sorry?
I'm not sure you can actually do what.
Yeah, I don't think you can do that either. Because it needs to be a type. It's like type off, I guess. Yep. Any more questions about some of the language features? Or can we continue? I have a few more things to go through before this is over. There are more things. We're going to get to C#7 in not too distant of a future, if I can predict that. So C#7 will most likely introduce a few things that Microsoft can from C#6 due to timing. They wanted to get as many good features as possible into C#6 and into Visual Studio, so they had to cut down on some of the features. The first thing we can see here is something called binary literals and digit separators. I can define binary numbers. I can separate my hexadecimal numbers using underscores. It's pretty handy if you do that kind of coding. We can initialize events inside our object initializers. These are features that they've had on the board and they have planned them and they have played around with them. They just haven't gotten around to do the support inside Visual Studio to get them in there. We can do field targets on auto properties, for instance. You can say here that the backing field for age is not going to be serialized. We could introduce something called a semicolon operator, which in this case, it would evaluate the entire expression as one thing. So what happens is that everything inside the parenthesis, first it'll introduce the variable x, set that to foo, it will print out the x, and then the entire expression returns x squared. It's pretty handy. So that's hopefully something we'll see in the future. And of course, params with INumerable. We can't do that today. Something called declaration expressions. Every time you use an out parameter, you have to first declare the variable before you do the call. Here, as you see on the bottom, we call and calculate age based on 1987. And if that is all fine, it'll produce this age variable for us. It'll just strip this out and put it on top inside behind the scenes here. The final feature that I'm really hoping to see in C#7, which they recently announced they're not doing for C#6, is primary constructors. Primary constructors would allow us to specify variables on our class declaration to say that these here are passed into the primary constructor of this object. So I could, for instance, initialize my auto properties or my read-only auto properties with the values passed to my primary constructor. And there's most likely more things going to happen. They're most likely going to change this around and maybe not even do any of them. So we can do more things with Roslyn. Roslyn exposes the compiler's APIs, which means that we can create really powerful plugins using Roslyn. We can, for instance, analyze code, and we can rewrite code. So with Visual Studio 2015 and with Roslyn, something called analyzers are being introduced. What this means is that you can pull down a NuGet package, and inside the NuGet package, you also get specific information about how to analyze your code. For instance, the code could find the usings of regions and tell you to stop using regions and get rid of them all, which is pretty handy. And you could do even more advanced things like extract your class to a new file name and do things like that. So imagine breaking down popular tools like ReSharper into small NuGet packages and just pulling in the ones that make sense for your business. And I see this evolving into something really cool for enterprises, where they can build up their guidelines, push them to their internal NuGet, and then just have everyone pull that down, and it'll tell you how to write your code to conform with their guidelines. So in summary, to summarize what we've seen here, we've seen that C#6 is going to be pretty awesome. And the work behind C#6, that's pretty cool. They've done a lot of work with the compilers. It's very awesome to see that they've open sourced it. And only us open sourcing it doesn't only mean that it's source open. It means that they're doing the work in open. It means that all documents from their meetings is there. You can participate, you can do pull requests and all that. So they're really looking for people to work for free. Sorry, I didn't say that. And there's a lot of change in C#6. Some of them are just small syntactic changes, and some of them are larger ones that really impact the way that we write our C# code. And doing this rewrite of the compilers, the .NET compiler platform, also known as Roslyn, means that it's much easier for Microsoft to improve and extend the programming language. And we could possibly see a lot of interesting things happening in C#7, especially around primary constructors, binary literals, and all that. Do we have any more questions? Yep.
Yeah, considering the compiler's been rewritten to C#6, how confident would you be to apply it to an old legacy piece of code and just build and deploy it? Are you confident? Do you think it does a good job of reducing all the problems in the old compiler?
So your question is, how confident would I be to take the new compiler and compile old code and push that to production? Very confident. The reason I'm very confident is that they've put a lot of work making sure that the new compiler generates the same IL as the old compiler for the majority of cases. They've had this out there for a while. The Roslyn compilers has been shipped as plugins for Visual Studio 2013. They've collected a lot of information. They know what kind of problems they're looking for to solve. And given that they're putting this in Visual Studio 2015, I'm very confident that it will work with all your old C# applications. Any more questions? I'll give you a book if you ask a question. All right. Thank you so much for coming. It's been awesome. I hope you like C#. Oh, you have a question?
I actually do have a question. There's something that I commonly do when I refactor, I accidentally forget to get rid of the little semicolon when I bring a line up.
Yep.
If I do that, is there a setting in the new Visual Studio to just pre-warn me that I've accidentally put a semicolon inside? But I do that when I refactor all the time. It always breaks my code and it always won't keep loading.
You could possibly write. So your question is that you want to spot errors when you're refactoring?
So there's one of the features in there where you say that if you go semicolon bracket, you'll execute part of the query. Yep. So what I'm saying is like when I will refactor down code, sometimes I'll go delete part of a line and bring another line up, and I'll actually forget a semicolon halfway through. So while I'm learning the new way of doing things, is there a setting to go, hey, Chris, did you intend to do that warning message?
I don't think there's something out of the box to tell you that you're doing something wrong that only you know is wrong. I mean, when you're refactoring something, the compiler will do what you tell it to, or the IDE will do what you tell it to. But with the addition in 2015 is that you do get this very nice preview of what is going to happen when you change your code. And if you look at this, you'll see that if you remove these two using statements, something might impact your solution. You'll see that if you remove these parts of the code, something will break. So you just have to pay attention. There's nothing here to start warning, like sounding warning bells when you're doing something you shouldn't, when you're the only one knowing what you should do. Does that make sense?
Yeah, that's what I was asking, yeah.
So this preview here is very, very nice, especially with larger solutions where you're doing a lot of refactoring. If there's a lot of things happening, it'll give you a lot of nice information about what you're doing. Performance compared to the old compiler, ideally it should be the same, meaning the code that is compiled is going to run the same as but you're saying the performance when you're compiling. It's better. I don't have any statistics. So you asked if there's any performance statistics for the new compiler. I do know that ASP.NET is using the Roslyn compilers to make compilations in runtime and to make compilations to memory. What they're doing is that when you're compiling code, instead of writing to disks each time, it just compiles to memory, and that makes everything very, very fast. And I have heard of some numbers about how much faster it is to compile with Roslyn, but I'm not confident to quote them. It's much faster. It's the new thing you should use. Contribute. Yep. Is there a planned release date? Not that I know of. The idea is named 2015, so I'd imagine sometime next year. Hopefully. If they don't bump the number again, you never know. They could change it to 2020 just because. Microsoft and numbering, I don't know about that anymore. Any other questions? Okay, cool. Thank you so much for listening to me. C#6 is going to be awesome. Go ahead and play with the new IDE. And thanks.